Hello everyone, welcome to Zarif Game Dev. In this part, we are going to remove a couple of bugs that were remained in the previous part, and after that, we are going to create one more method, which is just going to check for if any of the bubbles are present. So bubbles are just areas which cannot be solved, and we'll create a method to detect those bubbles, and we'll check if every that no bubbles are present, so every area is solvable. So we have bug right now. So the issue is we are able to select multiple areas, but there is an issue that it is not going through all of the areas. So as you can see, total it is only going through 50 of them. And as you know, for a 3x3 board, we have three solutions, and it goes through almost 100 checks. So it is only going through one, so that is the problem with the code. So let's go inside Visual Studio and let me show you. So the main issue is here. So we have our neighbors to be corner points, and according to this it is corner points, so we don't need to add plus and minus one or it will be problematic. And here we are going to add plus one minus one, and similarly the point y is going to be the neighbor. So x doesn't change, y is going to top and bottom, y doesn't change, x is going to be left and right. So that's why it is causing the problems. And let's go inside Unity, and everything should be fixed, and we should be able to see our all three of the results. So as you can see, it is showing three of the results, and the total number of grids created were 114. And again, if we go inside our 4x4 grid, it is going to show us all our 14,000 results. So as you can see, the total number of checks reduced by a pretty large margin. So previously it was searching for around 20,000, 30,000 checks, and now it is searching for only 14,000 checks, and the number is going to uh, decrease further for larger grids, as there are going to be uh, so many grids which have problems at the start, and they will be removed at the start. So the branching factor is going to be reduced much. Now the main issue with our current script is, let's go to the 15th and let's stop this here, and we'll have a speed of 0.01, and it runs at 800 speed. So if there are any bubbles created at the start, so as you can see, this is a bubble, this is never going to be checked, cause we are just going through uh, a new point, and there won't be any empty points selected, cause this is going to shows the minimum set, and whenever we created a new point, it is just going to be here, and this is never going to be solved. And what would happen is, it is going to check through every path that can be created till it reaches here. And there are going to be so many paths, as you can see, like for a path length of 100, there can be around 100 factorial paths. So the number is pretty large. So what we need to do is check if such bubble exists, and we were already checking for such bubbles before. So let's create our method first, and we are going to call this bubble remove, and let's open it up in Visual Studio, and let's go inside Visual Studio, and we are going to surround it with the namespace, and it is going to be connect dot generator dot bubble remove, and this is going to be our last trial script. And after that, we are finally going to generate our levels, and it is going to implement the generate method interface. And what we are going to do is copy everything from our graph random, cause it is going to be similar to that script. And the grid node and grid list classes are going to be similar, so we'll copy that. And our graph random script, we are also going to copy it. So everything is going to be similar. We are going to have grid list and grid node working similarly. The main issue is whenever we create a new uh, empty position, it is going to check. So as you can see, it is going to check for the minimum set, but it is only happening when we are creating a new empty position. And what we need to do is have this check at the start, and it should be before 0 empty. So after all our neighbors have been created, neighbors are empty positions, and after that what we are going to do is we are going to check whichever is not connected to a neighbor. So these are going to be the different areas, and we'll go through each of the areas and we are going to check if it's a bubble. So we are already doing a bubble check, but it is for just a bubble of size 1 where it is 0 empty. So 0 empty checks for bubble of size 1, but we also need to check for bubble of size 2 and 3. So size 1 bubbles are always unsolvable, we cannot do anything. Size 2 bubbles are also unsolvable, but size 3 bubbles, as you can see, they are always going to be solvable, and the rest will need to solve ourselves. So to do that, we'll need to pass a list of hash set of points, which is going to return our connected regions, and we'll call this connected set, and we are going to pass it here. And as you can see, instead of creating a new one, what we'll do is we'll pass here, and what it is going to do, it is going to modify this connected set list, and what our connected set list contains is all of the empty regions. Now it is also going to contain the empty region, which is which we are going to check next, create next, which we don't need to check. We just need to check the empty region which are not connected to our neighbors. So what we are going to do is we'll create one more. Yeah, will is not neighbor, low length, and get results list. So here we created the min set, and after that let's create a list of hash set of point, and we'll call this temp set, and we are going through loop through item in our connected set. And first we'll check bool is can add to be true, so we can always add. We'll add our item and we'll set this to a new item. And when we cannot add, so for each neighbor in our all neighbors, if our item dot contains, so it is going to be a hash set. If it contains the neighbor, then it is going to be false. So it is always going to be checked, so it does not matter. Naming we are already using, so we'll add can add to false, so we don't need to add that. And what we are going to do is after it is counting for the bubbles, we'll check in the end we need to add our connected set to be equal to our temporary set, and for each item in our connected set, if bubble remove dot is solvable, and we'll pass our item. So if it is not solvable, then we are going to return, and if it is solvable, then everything is going to work as we have intended, and we'll need to create this method here. So it is going to check for public static bool, and we'll call this is solvable, and here we are going to pass what we are going to pass, hash set of point, and let's just call this points, and by default let it return true, so every area is going to be solvable. And if our points dot count is less than 3, then we are going to return false, cause area 1 bubbles are already counted, and our area 2 bubbles are going to be return true. And if our points dot count is equals to 3, then we are going to return true. So every 3 bubble is solvable. So you should be able to see like every 3 cross 3 grid is going to be solvable. And if our points dot count is greater than 9, then also we are going to return true, or else we'll pass our current value and we'll individually solve it, and we'll see how we are going to do that. But for now, what it is going to check for is if it is less than 3, then it is going to be unsolvable. So previously we were only checking for just size 1 bubbles. Now it is also going to check for size 1 and size 2 bubbles, and if there is any size 3 bubble, then it is always going to return true. Greater than 9 is going to return true, and it is going to be problematic for greater than 9, which are the 4s, 5s and 6, but we'll create the method in the next part. Yeah, we will need to create a few more constructors. So let's see how this is going to work. So if there are not any errors, we should okay, so it is working. I don't know, but let's remove this component. We need to add our bubble remove script, and here we need to add our counter and the solutions. And now what should happen is we will not see any size 2 and size 3 bubbles. So as you can see, it is not showing us any size 2 and size 3 bubbles, but it is solving all this current paths which we don't need it to, and it is going through all of them, and maybe there are any invalid solutions. So again, that is problematic, but and again this is returning false. So let's check for -1. We first need to check like 71, and every result should be there. So let's pass the 16,000 and 0.5, and okay, let's add a little bit of delay, so our script always works. So currently we are just solving the paths, and before that we'll add a yield return new, wait for seconds, and we'll wait for 1 second, and that should just warm up our current So the total number of solutions. Mhm, mhm, mhm. So there are 74, and if we pass show only result, start coroutine, add to grid set, it should have been finished. So let's hit play. We are not able to see it. So let's hit play and we should be able to see all of the solutions. So again it is going to check for 74 solutions, and total number it checked for 148. And previously the count was 100, so it optimized a little bit. So let's see here. Our graph random was checking for 14,000 solutions, and it just decreased to 7,500, and the total number of solutions are going to remain same, so which were around like 200. And again our so let's have it 0.2. So the total factor was decreased. Mm, mm, mm. Again it is not showing us. So let's see why is it not showing us the only results. So if the only results are shown, solve paths is going to work pretty fast. So yield return null, it is going to be solved in just uh, one iteration. And if we go inside is creating show list and let it wait for 4 seconds, and then we can start showing. So our show list will be modified and we should be able to see it. So let's go inside Unity and let's hit simulate, and we'll wait for so we can't also check our grid counter text. So let's just remove this, and maybe our show list is not getting updated. Not show list dot, if show list dot next. And it is going to cause us some problems later, but let's go inside Unity and let's see what we can do about it. So our current show list.next is going to be null, then we don't need to do that. So I just put it inside the else, or it will be null and we won't be having anything. And it is show only result and not okay. So let's go inside Unity and let's see if we can see all of our solutions. Again it is not showing us the solution, so let's just remove that, and we are just going to undo everything that we have done. So let's go inside Visual Studio Can add is assigned but not used. Okay, so there is also this problem here. So it is going to be can add, then only will add, or it will create problems cause it is going to add every bubble. And I think that would be the only issue it may have caused. So let's now hit play and let's see if it is generating everything correctly. So as you can see, it searched for 12,000 solutions, so the previous were wrong. And what we can do is let's generate for our 7x7 grid, and we'll set the speed to 800, and it should give us almost so this is a 4 bubble which we need to check, and as you can see, larger bubbles will need to always check or it is going to be problematic. Can we get a solution fast? Okay, so most if we check if it is solvable and it returns true, then we can get a solution, but if it returns false, then it is going to go through a big loop, and that is going to be the big problem. And what we can do for now is we can always find a solution, and let's check for a random solution. And as you can see, we found a solution fast, almost in 100 to 200 tries. And currently we are not able to see all of the solutions, so let's fix that first. So we need to see all of the solutions, and our current speed is 0.02, and it is not even executing. Okay, so it executed, but there were some issues. So both of the solve paths would be just rendered in one frame. That is not going to be return null cause our current iteration speed is fast, and the point is it will be run on a different thread. So what we need to do is checking grid is equals to new grid list, and sol list is going to be checking list, and sol list is also updated. Just adding null was better, so let me go inside the previous build, and so currently are we inside the final game? Yeah, so we are inside the final game. Let's go inside the level generator, scripts, generate mesh, and we are going to go for our graph random, and our graph random was showing the results, but our current script is not showing the results. So let's set it to 0.5 and let's have it shown the result. It also won't work. We'll need to yield return new, wait for seconds, and let's wait for 2 seconds, and after that we are going to start creating. So it is going to wait for 2 seconds and then it is going to start creating. Doesn't matter. Let's go to 1600. Okay, so for our 4x4 grid, it went to 1600. Let's increase the speed to 0.05 and let's increase the speed to 16,000, and we are going to go inside -1. and just decrease it to 0.02 and let's hit play. So it should it is not showing. Let's go to the 0 and we are going to hit play. Okay, so it checked for 13,000 parts and there are 206 solutions. And what we can do is just check for -1, and even if it doesn't matter. So we'll wait for half a second and it just showed us all 3 or 4 solutions. So maybe the issue is on which thread our coroutine is working. So now it also again showed us all 3 or 4 solutions, and again if we go inside a larger grid, which is the 4, and let's set the speed to just 1000 and we are going to play, and what it is going to do is it will get us a solution pretty fast. So as you can see, in around 2 to 5 seconds it is going to return us a solution. So this is a valid solution, and most of the time the whole grid will be solved and it is not going to loop indefinitely when it starts with a bubble. So as you can see, this 3 cross 3 was solved pretty fast, and if there was any 2 cross 2 here, so if the neighbor was this, then it would have been deleted at the start. So that is the main advantage of checking bubbles, and all the 3-degree bubbles are passable, so that won't create issues. And what we are going to do in the next part is we'll use the current generator method, which is creating levels. We'll create a new boolean function. We already created that, but what it is going to do is if we found any of a valid solution for that set of points, then it is going to return true. But if the whole loops pass and we are not finding any solution, so the total number of checks are around 2 to 5,000. And we are also going to remove our hash set because it's an expensive function, and we'll do that in the next part. So in the previous part we created our bubble remove script, and what it does currently right now is if any of size 2 or size 3 bubbles are found, so it is going to categorize them. And what we are going to do right now is we will solve all of the bubbles. So if there are any regions created, then we'll check if that region is solvable, and if it is unsolvable, then it is going to set all of the neighbors and everything to null. So let's see how we are going to do that, and let's play our script again. So it is going to generate a level, and the level generation is still pretty fast and we can still optimize it. And so as you can see, it generated a level in around 200 steps. So now what we can do is let's go inside Visual Studio, and what we are going to do is our grid data class is fine, so we don't need to add anything. It is checking if any of the sets is unsolvable, then we don't need to do anything. But inside our solvable class, solvable function, which should be inside our bubble remove, so if it is greater than 9, then we are going to return true, and we'll do a check. So we'll see if it is solvable, then it is going to return true, else it is going to return false. So how we are going to do that? So we'll create a grid node as we have done in the start, which is our current node, and this node is going to be our current check node, so the naming doesn't uh, compromise. And we are going to create this as a new grid node, and it is going to have a different constructor where we are going to pass grid data, and dot level size, so we need the level size, and also we are going to pass our points. So let's see how our constructor is going to work, and after that we are going to have a grid node of next node, and everything is going to work similar. So while our current check node is not equal to null, then if for current check node dot data dot is complete, then we are going to return true. So if it is complete, that means our current grid is solvable. Else what we are going to do is we'll get the next node. So our next node is going to be our current check node dot next, and else if our next node is not equal to null, that means we need to go to the previous node. So our current check node is so if it is not null, then we'll go to the next node, else we are going to go to the previous node, so which is going to be our current check node is equals to current check node dot previous. And if it returns null, that means the whole loop is going to be finished and it was an invalid solution. And let's see how we need to create our current check node. So we'll need to create a new constructor where we are going to pass our points. So we'll need to first get our level size, and then we are going to create our hash set. So let's create a hash set of point, and we'll just call this points, and let's put this at the end because it's going to be a new constructor, and previous is going to be set to null, and after that our data is going to be our new grid data of level size, but it is going to have one more constructor in which we are going to pass the points, and everything else is going to be similar. Neighbor index is equals to 0, empty index is equals to 0, neighbors is equals to new list of point, and empty positions is equals to new list of point. And what we are going to do is for each item in our points, we are going to add our item which is our point, so it is going to generate from there, and after that we are going to shuffle our empty positions, and similarly when it is created at the start, we'll forget to shuffle. It will always start at the we need to start it at a random index, so we get a random position. So that is going to be the constructor, and here we need to do modifications depending on whatever points we have passed. So let's see how we are going to do that. So we'll need to create a new constructor in our grid data class, which is going to have a different parameter for an hash set of points. So let's create that, and int of level size, edges. Okay, so let's create a public grid data, and here we are going to pass an int for a level size and also an hash set of point, and we'll call this points. And at the start it is going to set it is going to be similar to our previous grid, so let's pass everything here, and not ing, let's copy this and let's paste it. So it is going to be similar constructor, but at the start we'll set it to -2. So everything is colored with some color, and what needs to be uncolored is going to be our points. So for each point in our points, our grid at our point dot x and point dot y is going to be set to -1. So everything else is colored and this is uncolored. Color ID is going to be -1, and after that, that should be it. So yeah, so that is it, and it is going to similarly check how our previous node was working, and let's see if get results list works similar. So it just sets the empty grid and everything else is going to work as it is supposed to be. Empty is just going to check for all the empty positions, and our next, and this does not have any connection with the color, and let's see where we are getting an error. So there are 6 errors. Else cannot start a statement. Okay. So I think it was not supposed to have an else. So if it is complete, then it is going to return true. Okay, so it was not inside this else, and this is going to set up our next node, and now it should not have any errors. And let's see how our current script works right now, and let's go to the -1 node and we are going to simulate. So if it has not any problems, then it is going to go through 47 solutions, and let's increase the speed to 10,000, and we are going to go for the 0. And what it was previously checking was around 7,000 nodes, and now it should not decrease much. I think it was 14,000 nodes, so now it decreased to around 10,000 nodes, and we are going to get all of the solutions. And let's hit play again. So the total number of solutions found were 196. Maybe there were some duplicates, and the solutions are almost pretty much similar. So let's go inside our script, and we are going to further optimize the script a little bit. And as you can see, if it is greater than 9, then we are eventually going to solve it, so it is going to return true. And here it is going to return true if it is complete. And what is going to happen is uh, whenever a neighbor creates an empty space, it is going to check for if that space is valid and its size is less than 9. And for less than 9 size, it almost gets a valid space in around 20 to 30 steps, so it is not going to take much time. And now what we are going to do is we can delete our rotations. So our script is working perfectly fine, there is not any problem, but our grid set comparer is expensive, so we will just delete that. And let's see what we need to delete. So we don't need the flip, rotate, and also the rotate, so let's delete everything here. And also we are not going to need our get similar, so we'll delete that here. And after that we are not going to need our grid set comparer because we are not using the dictionary. And so again there are 3 errors, so we'll need to remove our grid set comparer. We can also remove our grid set, and we should have a hash set of grid list. And after that, inside our not grid set, so we will also remove it. So we don't need to add all the similar, and again it is going to increase our search space, but let me show you how it is going to increase our current time. So if next node is not equal to null, then our temp list is going to be our new list, and our current node is going to be our next node. And if it is not null, then our temp list is not going to have any problems. Else is going to be similar, and we are just directly adding it. And when any of this passes, we'll need to increase the checking grid count plus plus. So what we did is remove the dependency for our add to grid set. So we don't need to add to grid set, we can also just remove that. So again we removed all the errors and our code should work perfectly fine, but what it is going to do is it will generate all 5000 solutions which were previously generated here. So as you can see, it gave us 5000 solutions, and let's have it to show only result, and we'll hit simulate. So as you can see, the total number of duplicate solutions were 400 if we just go through everything, and the total checks were 5000. But let me show you something. So let's go inside Visual Studio, and when we solve our paths, at the start we'll check if our current node dot data dot is grid complete, then we are going to yield break. So what it is going to do is it will just find one valid solution, and then the loop is going to end, and it is just finished in around 20 tries. And what we can do is so in the previous part we had some issues with showing the solution, so what I did was added a little bit delay, so our showing list just gets updated before we start showing. And we can remove this because we are just directly going to the so yield return new, wait for let's just wait for one frame, so one frame should be more than enough to set up our list. And now we can go inside Unity, and as you can see, within around 14 tries it found us a solution. And again the total number of tries are going to be less and less, and let's check for our zero grid. So in 15 tries it found a solution, and we can do this again, and the total number of tries are going to be around O of n square, which is the total number of cells. Now let's see how fast it finds us a solution for our 5x5 grid. So again there are 25 cells, and it found us a solution in 62 tries, and we'll pass this loop again. So it found us a solution in 25 tries, and we can do this again and again, and it is going to find us a solution pretty fast. Now let's see how fast it is going to be for our 6x6 grid, which is as 30 to 36 cells, so it found in 50 tries, and the maximum amount of tries it is going to take is going to be less than 100. So as you can see, again it found in 60 tries, so most of the time it is going to find pretty fast. And again we are going to check for our 7x7 grid, for which we need to generate all the levels. So again it found in around 50 tries. And we'll do this again, and here it took a little bit longer, but still it was in less than 100 tries. So we can set an hard limit. So let's see how fast it is going to generate our final solution. So here it took a little bit longer, but still it found us in less than 200 tries. And we can do this again, and again it is going to find us a solution in 250 tries. So some of the solutions were longer, some are shorter, and some are just we could have joined this too. And the main advantage of this method is we just remove the dependency on the hash set, and we don't need to find all of the solutions. So whenever we find one of the solutions, it is going to directly stored inside our where is our scriptable object, and we can update our levels. So let's check again how fast it is going to be for a 15 cross 15 grid. And again okay, we need to set the speed to 1000 so it does not crash. And let's see how fast it is. So again it just took 450 tries, and our 15 cross 15 grid has 400 cells. So the maximum amount of tries it is going to be taking is less. And let's try with 30 cross 30 grid. And as you can see, it generated us a level in around 1000 tries, and again it has almost like 3000 solutions, not 3000, 1000 cells, and it is going to generate pretty fast. So we don't have control over how our grid is going to look, but what we have control is how fast our solutions are generated. And most of the solutions for our 7 cross 7 grid are not going to look bad, because it is going to, so as you can see here it went inside an infinite loop. Maybe it doesn't have a solution. Yeah, so as you can see that caused a problem here, cause this grid is not having a solution. So it is going to happen sometimes, but what we can do is we can restart the process again, and it is going to find us in 200 tries. And we can set a hard limit to how much we want to search for. If we don't find in less than 1000 tries, which is going to be for our 7 cross 7 grid, then we can restart the process again. And if it reaches like some unsolvable state, then the main issue would be like it created a large area, and for that return true, and we set return true for greater than 9. So any space greater than 10, it is going to solve through all of them. And again as you can see at the start, our 9 cross 9 grid had almost like 5000 solutions, and it is going to check through all of them. And suppose it happens at the start, and it is going to happen multiple times, then we can like just restart the whole loop again. So as you can see here, it took a little bit of time, but the total number of solutions are going to be found in less than 1000 tries. So that's what we were supposed to do, and we can generate a whole level. And after that what we can do in the next part is when this loop ends, we are going to store it inside our scriptable object, which is going to be our levels. And it generated so many levels, so there are so many of them. Let's just remove most of them, and we can delete everything here. And let it generate for our 7 cross 7 grid, and it is going to generate and add one level. So this is our level, and currently as you can see, it is going to be empty. It doesn't have any edges. So we are going to store these edges in our grid data, and when the level passes, we are going to update those edges, and store them inside our scriptable object. So that was it though for this part. And after we have generated all the levels, our current game should be finished and you should be able to play all of them. So in our current part, what we'll do is we'll store our edges and we'll set them up for our scriptable object. So let's go inside Visual Studio and we'll need to create our edges inside our grid data class, and we'll need to set them up. So where should we create our edges? So it should be inside our grid data. And where is our grid data? And we are going to have a public list of edge, and we will call this edges, and we need to initialize at start. So our edges are going to be a new list of edge, and that is going to be for our ij. So our this one has 0 references, so we can delete that. It is not going to cause any problems. Now what we need to do is how our edges are going to be updated, and also in our constructor we'll need to set up the edges. So both of them needs to have edges cause it is going to access this function. So let's first inside our grid copy, let's create our edges, and it is going to be a new list of edge, and we cannot directly set it from the grid copy cause it is a list, and it is going to modify the list. So for each item in our grid copy dot edges, let's create a temporary edge, and not edge, temporary edge is going to be a new edge, and temporary edge temp dot points is going to be a new list of vector to int, and for each point in our item dot points, we can add temp dot points dot add point. So it is going to add all the point, and after that it is going to add our edge. And our color ID, let's first set, is going to be our grid copy dot color ID, and if our past color is equals to our color ID, that means both of them matches. So what we can do is edges at edges dot count -1, which is our last edge, and for that points, and we can add new vector to int, and we can pass our ing. If it is not, then we'll need to create a new edge and we'll need to pass that. So we have to do is edges dot add, and we'll need to pass a new edge, and for our new edge our points is going to be new point. So as you can see, we created a new point and we passed our new point. So it is going to create a new point and add it. So it created a new edge for which we initialized our points, which is a new list, and for that list we initialized with our current position. and that is going to happen if our past color is not equal. So we are going to create a new edge, and inside our so do we did any modifications inside our graph random? Okay, so the only modifications we did was okay. So when our loop ends, what we can do is before yield break, let's go to our scripts, and it should have using connect.common inside our level generator where we had our current data. So it should be before we have created it button function, so it will be private. So private game object, private, so this will set it as public, and what we can do is set our instance dot current data dot edges is going to be our not here, not inside our generate paths, it should be inside our solve paths. Instance dot current level data dot edges is going to be our current node dot data dot edges, and we can check if it is working. So we will go inside Unity and let's set this up for our -1. So we'll hit play, and what should happen is it should generate three edges, and let's see. So for the y is equals to 1, it starts from 0, 1 and 2, that is one edge. For y is equals to 0, it starts from 2, 1 and 0, so that is other edge. And for y is equals to 2, it is going to start from here. So it updated our edge. So let's see if it updates the edges again. So there are two edges and they are added to our scriptable object. And let's go inside Visual Studio, and now what we need to do is so are there any more changes? No. So there are not any more changes in the next part. Yeah, so that's how we are going to add uh, one of our scriptable object, and we are going to use this scriptable object inside our project, which is our game. And the level generator is not going to be added to the build, so it will just set it up normally, and it is going to be updated inside our level. So as you can see, there is our level 70 and level -10, and let's see if add the edges for our level 7. So our level 70 is currently empty, so what it should do is it should populate all of the edges. So as you can see, there are 17 different colors, and everything has been populated. And now if we simulate again, it is going to have different amount of colors. So there are 21 colors and they are also added again, and we can do this again and again, and it is going to set up our current level. So this took a little bit longer, so it took almost 630 tries, and again it added all of our edges. And to see if all of our edges are valid, we'll need to check it inside our game. So if so they are almost valid, so let's pick a random edge, which is this. So this starts from 1 1, which should be here, then it should go from 1 2, 1 3, and then it goes x is equals to 2 and y is equals to 3. So every edge is valid, and we created a single scriptable object, and now we don't need to visualize anything. So what we are going to do is, depending on our current bubble random script, which is going to be our generate methods, we are going to create another script which will just give us all the levels, and depending on that we are going to set all 50 of our levels. So we are going to do that in the next part, and let's see how we are going to do it. So let's create our function which is going to generate all of the levels. So we'll go inside Visual Studio, and most of that is going to first happen in our node renderer, level generator. So our level generator is going to have most of the modifications, and level generator single, and we need to go to the level generator and spawn board and everything, button function, generate single level. Generate default, here we'll pass hashtag region, generate single level, and this region is going to go through here. So it is going to generate single level. This region is for node rendering, and this is going to be the region for our button functions. And after that we are going to have a region for our generate all levels, and we'll create an AND region, and this is going to be called inside our all levels. So so we'll call this generate all, and it is going to be a private void generate all, and it is going to be a coroutine. And what we are going to do is we'll call the generate all levels coroutine, and we'll need to create that coroutine. So let's create as a private enumerator generate all levels, and inside our generate all levels we'll pass a for int I less than 51, and we are going to yield return new wait for seconds. Let's wait for 0.2 seconds, and using system.collection, so it does not show any error. And what we can do is yield return generate single level data, and we are going to pass the I, and our counter text dot text is going to be equal to I dot toString. So we'll need to create a serialized field private tmp text, ttext, and this is going to be our counter text. Am I recording? Yes. So counter text, and we'll need to create our generate single level data, and it is going to be similar to how we generated our single level, but here we are going to pass as a coroutine. So let's copy this first. It is going to be similar, and generate, and it is going to be single level data, and we'll have it as enumerator, and let's pass yield return null here, so it does not show any error. And it will create issues because our generate method is coroutine, and our current level data will be updated and there will be some collision. So what we'll need to do is create this generate method as a coroutine, and yeah, so we'll need to create that generate method as a coroutine, and we also need to store our result. So let's go inside Unity and let's create our final script, which is going to be our level generator single. And this is our level generator, this is our level generator single, and let's open it up inside Visual Studio. So previously we were using our bubble remote script to generate all the levels, but now the method is going to be a little bit different. So we are just directly going to generate all of the levels here, and it is just going to show a counter of how fast the levels were generated, and it is going to calculate from here. So so what we are going to do is we are going to copy our node and the data class, and we are going to paste it here, and it showed so many errors because we are not referencing our namespace. So it is going to be inside our connect.generator namespace, and now the error should be removed and we don't need that. And still there are some errors, which is a list of edge, and our edge is going to be, we'll need to set one more using, and it was inside our connect.common. So again all the errors would be gone, and we added yeah, so we added so let's add our data classes, and our data classes just have methods, so they are not going to have anything. And here instead of bubble remove, we are going to use level generator single, and we'll need to create that method. So everything is fine, and now what we'll do is we'll copy our whole methods from here, and let's see what we'll need to change. So we are not going to need the grid list, so we'll just remove the list, and we don't need to check if our current node is null, and again we are not going to need both of the lists. No list needed here, and also no list needed here. And it is not even going to have the start coroutine. It is not going to have this whole loop again, and instead of start coroutine, what we'll do is we'll yield return, and we'll pass our solve paths. And we'll need to remove our solve list. We again don't need that. So our generate is going to be an enumerator, and here we are going to need different nodes. So let's remove timer text. Yeah, we are going to timer grid count text, and let's just call it counter text, and private int Do we need the speed serialized field? Yeah, let's have a private int for our speed, private int for our temporary count, and private int for our counter. So it is going to have implemented differently, and we are not going to have any start functions. We'll assign everything inside our generate, and here we can also public static bool grid data dot level size cannot convert from int to grid data. Okay, so that was just the so everything is going to be inside our generate method, and let's first set our counter to 0, and after that we'll set our temporary counter to 0, and we'll need to get our instance, which is going to be get component, and this is going to be our level generator. And after that we'll create our grid node, which is going to be our current node, and our current node is going to be a new grid node of instance dot level size, and our current node is going to be current node dot next. And let's create a new grid node, and we'll call this next node. And our generate paths, we implemented that method inside our generate, and our so what we are going to do is copy this whole script and paste it here, so it is again going to do the same thing, and we are going to remove our solve paths. So we don't have any checking grid count, so let's see what we need to do. So grid node next node, if data dot is grid complete, then instance dot result is going to be current node dot data. We'll need to pass a result, and we are going to have this inside our level generator, and it is going to be of the type grid data, and we'll just call this result. And when we have let's do it next, and after that we are going to set the next node, and if next node is null, then everything is going to be working fine. And current node dot previous, if current node is equals to null, then we'll just yield break, and the counter is going to work differently here. So instance dot render grid, what we are going to render is our current node dot data dot grid, and we'll increase the counter, and after that we'll increase our temporary counter, and we'll set our counter text dot text is going to be counter dot toString, and if our temporary count is greater than speed multiplied by time dot delta time, then we'll set the temporary count to 0, and we'll set yield return null. So again it does the similar thing while our current node is not equal to null. But before that, we are going to check if our counter is greater than 1000. Then we are going to repeat, and let's set a limit of 5000. So what we'll do is we'll yield return, so it is going to call the method again, and when it ends we are going to end. So we just updated everything to use coroutines, and that is how our final generate method works. And it is using our grid node, which is a node for our graph, and our whole puzzle is stored inside our grid data class, which has each of its fields and also the results we need. And after, where is the error? Type or namespace and of definition added. Okay, so now is it showing any errors? Level generator single, and we'll need to update our level generator, and instead of get component generate method generate single level data, we'll have it get level generate, and what we'll do is we'll yield return. And after that has done, we'll set the current level data dot edges is going to be result dot edges, and also our we need to render our result. So we are going to pass our render grid function, and we'll pass our result dot grid, and we'll wait for 0. Yield return new, wait for seconds, and let's wait for 0.4 seconds so we can start generating a new level. And by default it is 0. Here we are passing the I, and we need to start from 1, and it is going to go from 1 to 50, and it should not have caused any errors. And let's remove level generator single script. And why is there? Okay, so level generator single script is going to need a counter, and this is also going to need a counter. So let's pass the solutions inside our level generator counter, and counter inside our counter, and let's pad the speed to 1000. And after that, let's see if we have done everything correctly. So the only thing that can happen is either my game crashes cause there was so many things that we needed to do, and we didn't check everything if is working fine. So let's hit play and let's see how it is going to work. So as you can see, it generated in almost a little bit of tries, and it is generating all of the levels, and the previous speed is pretty fast, so that's why we are not able to see it. And let's set the speed to around 25, so we are able to see it. And for our prefabs and our levels, let's just have it at 1, and we are going to delete all of our next levels, so let's delete that, and we can just directly set it at our current level, which is going to be our 1. And so let's see how it is going to show us. So as you can see, all the levels are getting generated, and we would be able to create all 50 of our levels, and after all of these levels are generated we should be able to play them inside our game. So as you can see, on average it is only taking around 20 to 100 tries. Maybe sometime it will take larger, but we can always go to the next step. So it generated all 50 offer levels, and to check if all the levels were generated, we can go inside our main menu and we can start playing our current levels. So as you can see, this is our first level. This is okay. So edit, clear all player prefs. So we cannot directly go to the next level. It is only going to work if we have cleared that level. So let's just play this level and clear it, and we will see if our next level is different. So as you can see, our next level is different, and we generated all of our levels and they are generated randomly. So now what we'll just need to do inside the next step is let's see how all of our levels are going to be generated. And the game is pretty fun, and if we go and play our this is just going to be the default. Now let's start generating all of our levels, and finally our game should be finished by then. And what we need to do to generate all of the levels is going to be pretty simple. So our levels should have 51 levels, and let's go inside our level generator, and inside our level generator scene, and we'll generate for our 2. And for now we are going to use a little bit of slower speed. So let's just use a speed of 10 so we can see how everything works. And let's hit play, and we should be able to again it's still pretty fast. Let's just use 4 so we are able to see everything, and the rest of the level generation is just going to be me showing all of the levels. So as you can see, it is generating all of our levels, and we are going to do that for all of our levels. Let's decrease the speed to 2. Mm, mm, mm. Mm, 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 So let's just directly generate all the levels first, and then we are going to visualize it. So level generator has a little bit of delay, which is 0.1. We can just have it at 0. We can go even lower. Let's set it at 0.08f. And our level generator single also has some delay, where our temporary count is going to be greater than speed. What we can do is directly increase the speed. So our current speed is a little bit slow. We can have it at 1000. So 1000 works fine for our all of the levels. And let's now generate all 50 of our levels for our 2x2 grid. 4, 5, 6. So again, I think it is pretty slow. For visualization, we are going to use a different method. Are we having any duplicates? No. So let's increase the speed more. So instead of for our level generator waiting for some amount of seconds, let's just wait for 1 frame, and it is going to automatically show us all the levels. And our game is currently finished. The only thing we need to do is generate all of the levels, so I'm just going to speed it up. You maybe hear some background noise because I just live around where the main road goes around, so it is going to take some time. So it should have generated all of our levels, and we can see that the total number of levels have been set. And let's do it for the stage 3, and let's see where most of our time is spent. So instead of waiting for 20 to 30 seconds, I want to just have it instantiated instantly, generate single level. So here is the delay. Now we don't need to do anything. So that was the delay, and now it should work fast. And let's generate all of our levels first. So as you can see, it is generating almost fast, and we should have more of the levels. Let's go inside our 4x4 grid. uh, Fourth level, it is going to be, I think, so somewhat it somewhere it took around more tries, but everywhere else it was fine. Let's generate for our fifth stage, which should be 10x10 grid. And again, it is going to be, so this one is going to be take a little bit more time, but when it reached 5000 count, it just restarted the loop again. And we can increase our speed more, so let's set the speed to 5000, so it will just finish that in one single loop. So as you can see, where there is a little bit of delay, there we would have that some problems with the arrangement, but it just happens one in around 50. So if we just restart the loop again, it won't happen next time. So as you can see here, it took a little bit more time, but for the larger levels it is going to happen more, but most of the levels we can just restart the loop again, and it is going to generate all of our levels. And inside our levels we should have almost 351 levels, and we can go inside our project, which is going to show our main menu. And what we need to check if all of the levels are loaded perfectly fine. So let's go inside novice. It has a different arrangement. Regular, again it has a different arrangement. Regular B, okay, yeah. So the regular B and all of that, there is some issue with the color, and what we can do to fix it is whenever our color is getting stored, so we'll need to fix that. So inside our project, so level generator has done finishing that, if I didn't see it. So these are our scripts. Our node is not going anywhere, so all of our where are our colors stored? We can directly check it. So our game manager doesn't have the colors. It should be inside our gameplay and inside our gameplay manager. So these are the node colors. And let's go to our gameplay manager script, and let's see where our node colors are getting referenced. Board spawn button. So where are our node colors? Board spawn, does it have color? Node spawn, get color ID. Go to definition. So here are our node colors and find all references. Where is find all references? Okay. So these are the three references where our node color is getting used. And node colors of color ID. And what we can do is we can percent this by our node colors dot count, and again instance dot gameplay manager dot instance dot node colors of color ID percentage it by gameplay manager dot instance dot node colors dot count. And again there would be one more instance, so where is it? Inside our add edge. So we are going to percentage it. So for now I just have all of the 11 colors and I don't think it needed more, but you can add your own colors and it is just going to show duplicate colors, and it will create confusion for now, but I'm not going to add all of them. So I thought 11 colors would be more than enough because the total size was 11. And now there should not be any problems. So let's go inside our gameplay manager, and for our colors, this is our game manager. Let's find our references. So wherever we are getting, we should percentage it by the count so it does not show up any errors. So as you can see, that should work out our out of bounds, and to have different colors we'll need to add it, but this method works fine. And now let's go to our scenes and main menu, and now we should be let's use simulator, and it is looking pretty bad. Apple, iPhone 13. So it has an arrangement for 13. And now let's hit play, and we should be able to see all of the colors, and we'll just directly get to the end. So there were duplicates, but you can add your own. And again we are going to go through the expert. It has all the colors. And again the advanced and regular, again it has all the colors. And let's play our noise. So most of the solutions could be uh, uh, uh. Hmm, hmm, hmm. Mm, mm. Okay, okay. So this needs to be. Hmm. So now this is going to be a valid solution. So as you can see, the novice B is a little bit difficult, and novice A, the fifth level, again, this one is going to be different, and that is going to be your final game. And if you guys watched till now, then thank you for finishing the whole course. And this one was a little bit harder, so I needed to learn how to traverse through graphs, and uh, instead of lists we need to use different data structures, and it took almost 1.5 month of practicing. And also while creating the game, you also know that we generated a few bugs, and it had been so long that my game had bugs because I was just trying similar games and most of the methods and how the code game is coded was similar. So it is good to have bugs. It shows that you are learning new things and there is something you don't understand and you want to understand, but the level should be perfectly fine or it will be frustrating. So I just I started creating this game on November, and I just took a break for almost 15 to 20 days, and after that there was a little bit of health issue, so I just left it for around 1 month. And after almost practicing the data structures which are for the lead code, I went through the binary trees and the graphs, and also how the linked lists, queues and stacks are used. So as all data structure is almost similar, so we just use similar to linked list to show off all our generated levels. And if I knew if I knew already that how is it is going to work, I didn't need to create that, because as you can see in the final code, like it was too clean, and it had not any extensive methods, and we didn't even need to check. So previously it was if I use the lists, and if you have like used the list to generate even the 4x4 method, your editor would have crashed. And finally that was it for this game, and this would be the final update. And uh, I finished it, so what else to say. And you can get the game from the GitHub repo, and I'm not going to build it for the mobile because there's already the Flow game which has almost like millions of dollars revenue for almost every year. So if you want to like publish your own game, you can update the graphics and add some animations. And this is almost like if you see inside our project scenes, and let's go inside our scripts. I also didn't add the sounds because it was not necessary, and I can add it, but it's not going to matter. And as you can see, it is a minimum amount of assets. So we have the board, we have the circle, and these are some of the assets for the UI. We just set the color, and again we created a good game out of it. And I'm not too good at art, so I'm just going to leave it at here, and you can create your own game afterwards. So thank you guys for watching, and see you guys in the next one.